this is mth a, then a to the power n means a into a into a, this is nth a. We can also prove this. A to the power n divided by a to the power n, numerator a to the power n, that means there is product of m number of a's and this is product of n number of a's. Good morning, welcome to btosacademy, welcome to my maths class. Today I am going to start new topic, logarithm. Already I have written on the board. Logarithm, actually when we discuss sums in calculus, derivatives, integration, frequently we need logarithm, but students feel uneasy. That is why I decided to discuss this topic, logarithm. Also, logarithm is associated to the topic laws of indices. That is why I shall first discuss laws of indices and then logarithm. That means logarithm and laws of indices will be discussed now side by side. First of all, laws of indices. First, let me discuss the symbols. A to the power n. A to the power n, meaning of a to the power n is product of n numbers of A. A is called base, n is called index, power, also exponent. Therefore, a to the power n is a into a into a. This is nth a. Next symbol n, a to the power n. N is the coefficient of a to the power n. Next, we shall discuss laws, symbols with meaning. Then laws. Number 1, I call it serial 1, now serial 2. A to the power n into a to the power n is equal to a to the power m plus n. We call it product law. A to the power m into a to the power n is equal to a to the power m plus n. Let me clarify. A to the power m into a to the power n. A to the power m already I have discussed. This is a into a into a into a. This is mth a, then a to to the power n means a into a into a. This is nth a. Now if I remove the brackets, then how many a's are there? A into a into a. This is totally m a's are there. Here totally n a's are there. Therefore, in total, n plus n number of a's are there, which is expressed a to the power n plus n. If we know the reason why we get this result, then it will be quite easier to remember. Therefore, this is the product law. Then number 2, a to the power m whole to the power n, that will be equal to a to the power mn. Now why? Proof. A to the power m whole to the power n. Already we know a to the power n means product of n number of a's. Therefore, it is product of n number of a to the power m. This is nth. Now, as per this product law, product or multiplicative law, we will have the powers will be added. M plus m plus m. This is also nth m, and that is equal to a to the power. There are n number of m, therefore sum will be a to the power mn or nn. Next, number 3. AB whole to the power n, that is equal to AB into AB into AB AB whole to the power n, that is equal to product of n numbers of AB. Now, if we take all a's together, this is a into a into a into a. This is nth a into, we take all these together, therefore it will be b into b into b. This is also nth b. Therefore, this is expressed by a to the power n into b to the power n. Therefore, ab whole to the power n is equal to a to the power n into b to the power n. Now, we can take this corollary. Similarly, a by b whole to the power n is equal to a to the power n by b to the power n. All these three are related to multiplication or product. Therefore, this is the fundamental law of index. Fundamental law of index is this. This is called fundamental law of index. Then from that we get next one, a to the power m whole to the power n is equal to a to the power mn. Next we get ab whole to the power n, that is equal to a to the power n into b to the power n. Then a by b whole to the power n is equal to a to the power n divided by b to the power n. Next we have in case of division, a to the power m division a to the power n, which can be written in the fraction form, a to the power m divided by a to the power n, numerator a to the power m, denominator a to the power n, that is equal to a to the power m minus n. That is known as quotient law. A to the power m divided by a to the power n is equal to a to the power m minus n. We can also prove this. A to the power n divided by a to the power n, numerator a to the power n, that means there is product of m number of a's and this is product of n number of a's. Now if we cancel those like this, proof a to the power n by a to the power n, a into a into a into a, this is mth a, and denominator is a into a into a, this is nth a. Now nth a will be cancelled from numerator denominator, then we will have finally a to the power m minus n. Next, number 2, a to the power 0 is equal to 1. That is definition, taken as definition. One thing that is to be mentioned, when a is base, a never 0. Note this one. A is non-zero. Now a to the power 0 equal to 1, that is taken to be true as definition, though we can explain that in case of real numbers, a to the power 0, where a is real number, a to the power 0 can be written as a to the power n minus n. Now as per this quotient law, it will be a to the power n by a to the power n. Now division of a number by itself, the result will be 1. In case of real number or rational number, we explain this law or formula like this, but actually it is taken to be true always, that is why definition. Next, number 3, a to the power minus n, that is equal to 1 by a to the power a. Proof is this one. e to the power minus n can be written as e to the power 0 minus n. Now, as per quotient law, it is e to the power 0 by e to the power n. E to the power 0 is 1. Therefore, finally, e to the power minus n equal to 1 by e to the power n. Next formula, nth root of a to the power n is equal to a to the power n by n. This is actually taken as this is index form, this is radical form. Nth root of a to the power n is equal to a to the power m by n. This is not quite new, that is just notation or symbol. For example, square root 2, that is equal to 2 to the power half, cube root 7, that is equal to 7 to the power 1/3. Next, number 4, if a to the power m is equal to a to the power n, where a is not equal to 0, then m equal to n if a is not 1. In case of a equal to 1, 1 to the power m, that is equal to 1, 1 to the power n, that is also equal to 1. Therefore, we cannot conclude about mn. Now, if a is not equal to 1, then we can say that e to the power m is equal to e to the power n will give m equal to n. Next, number 5, e to the power n is equal to b to the power n. Here powers are equal, then either n equal to 0 or a equal to b. If a to the power n is equal to b to the power n, then either n will be 0 or a equal to b. That means if powers are equal, then bases will be equal or those powers will be 0 each. These are the laws of indices. Logarithm is closely related to laws of indices. That is why I have discussed first laws of indices, then we move to logarithm. A to the power x equal to b. Equation from a to the power x equal to b, or b is the value of a to the power x. Here we consider the restriction: a is non-zero, b positive, a greater than 1. A to the power x is equal to b. Now, we express this index, then x is expressed by log of b to the base a. A to the power x is equal to b. B is the value of a to the power x. Also, if x be unknown, we can treat as equation. Then we express this index x by this form, x equal to log of b to the base a. This is definition. Now I replace this one here. Therefore, a to the power log of b to the base a is equal to b. This is the first formula. If you see these two are same, the value will be b. Remember like this. Next we have, if a to the power x equal to b, then if we raise to the power n both sides, then what we get, a to the power nx is equal to b to the power n. Therefore, I can express this in terms of logarithm. B to the power n is equal to log of b to the power n log of b to the power n to the base a. I can express that. Therefore, log of b to the power n in terms of logarithm, this one will be this. Therefore, log of b to the power n to the base a is equal to nx. Already we have got x, this one. Therefore, n log of b to the base a. Log of b to the power n to the base a will be equal to nx. Now substituting x by this one, we get this one. This is the next formula. Now we can use this definition. Take few examples. Three square is equal to 9. Now I can express this log of 9 to the base 3 equal to 2. As per definition, 3 square is equal to 9 means this one. Also, if it is given, then we can write this. Number 2, a to the power 0 equal to 1, from which we can write using the concept of logarithm, log of 1, and already mentioned a is non-zero, therefore log of 1 to the base a equal to 0. Also we can take this one, a to the power 1 equal to a, therefore in terms of logarithm it will be log a to the base a is equal to 1. Next, we move to the laws of logarithm. log of m plus log of n is equal to log of mn. We can also say reversely, log of mn equal to log m plus log n. Here bases are not mentioned. If we mention the base, it will be like this: log of mn to the base x is equal to log m to the base x plus log n to the base x, product law. Then we have log of m by n to the base x is equal to log m to the base x minus log n to the base x. Then we have log of a to the base x is equal to log of a to the base y into log of y to the base x. This is called base changing formula. These are the three laws will be discussed initially. First, let me prove this one. For that, number one, let log of mn to the base x equal to p log of m to the base x equal to q and log of n to the base x equal to r. Now, as per definition, therefore x to the power p is equal to mn, and from this x to the power q is equal to m, and from this x to the power r is equal to n. Now we start from here. Now mn is equal to x to the power q into x to the power r, or x to the power p is equal to x to the power q plus r as per laws of indices. Therefore, from it we get p equal to q plus r. Therefore, putting the values of qr, we get log of mn to the base x is equal to log of m to the base x plus log n to the base x. Similarly, you can prove this one. I advise you prove yourself, learners of 11-12 standard. You prove yourself this one. Now I prove the third one. Put let log of a to the base x equal to p log of a to the base y equal to q log of y to the base x is equal to r. Now from these three we get x to the power p equal to a. From this y to the base power q is equal to a, and from it x to the power r is equal to y. Now x to the power p is equal to a, also a equal to y to the power q. Now we have the value of y, therefore x to the power p, put the value of y, this will be x to the power r whole to the power q, and from laws of indices we have got this is equal to x to the power qr. Therefore we get x to the power p is equal to x to the power qr. Therefore p is equal to, bases are equal, therefore powers will be equal qr. Now putting the values we get log of a to the base x is equal to log of a to the base y into log of y to the base x. This is the base changing formula. Now putting a equal to x, putting a equal to x, what we get from here? Therefore log of a to the base a is equal to log of a to the base y into log y to the base a. Now log of a to the base a is 1, therefore log of a to the base y into log of y to the base a is equal to 1, from which we can write log of a to the base y is equal to 1 by log of y to the base a. This is deduced from this original one. If we put a equal to x, left side will be log of a to the base a, which is equal to 1. Therefore right side will be log of a to the base y into log of y to the base a, from which we get this one. Now again we can deduce from this one what we have got, log of a to the base y is equal to 1 by log of y to the base a. Now this one can be written as log, here base is a, therefore 1 can be written as log of a to the base a log of y to the base a. Now if we omit these bases which is common, therefore log of a to the base y is equal to log a by log y. Here we have omitted A. Thus, we have discussed all the first three laws of logarithm.